Hello, my name is Greg, and some time ago I participated in the AEC hackathon in Wrocław. During that event, I had occasion to learn something new, something completely new for me, the new Beam Viewer. And what is the most interesting, it is completely open source. You can check the internals and you can use it into your own purpose, like we do during the hackathon. And I think that that particular web viewer, it deserves a little more light, a little more details about how you can use it and what differentiates it from other solutions. So let's see. During the hackathon, we used Xeokit, and as you can see, there's quite a lot of data on their website. You can check the features, the samples, all of that is available. But for me, the most interesting part as a developer are internals. So on the GitHub, there are a few repositories involving Xeokit. And here we see the Xeokit SDK, the backbone of the whole Xeokit ecosystem. So there you can find how they solved a lot of tricky issues with the viewing big Beam models in the web browser. But also there is the built, ready to use, the Beam Viewer, which has all of those features like the tree for the stories, for the classes, the object properties, which are currently selected, all of that stuff. There are also some other repositories, but yeah, we will go into them a little later. So the Xeokit is available for anyone, and you can always check how it works. But now I just want to run a demo to see, okay, so what exactly is that Xeokit? So I will pick some, let's go with this sample Rabbit IFC model. And now we are loading the data, and after a while, the whole model is there. And as you can see, the level of details, it depends on do you zoom, do you zoom or not, sorry. So the Xeokit has a lot of features, which makes, for example, this one. When I am quite far away from the objects, the zoom is pretty quick. But when I am close, then you see that the same movement of my scroll, it makes the movement much smaller. So when you want to look into the internals of your building, then it's much easier. Of course, you can select some objects or maybe change what do we see. And now we see just the architecture. So let's disable some story. Let's disable the roof. Okay, maybe also some floor to see the internals. Nice. And if I will select something, for example, that column, and go to the properties, then I see all of those property sets which were in the IFC file. And yeah, that's just the Beam Viewer, as you could expect. But what makes the Xeokit unique, I would say, is its performance. So that sample Rabbit model was not so big, but now let's look into that hospital. And during the hackathon, when I was just playing around with those samples, I opened that, and yeah, just look how quickly it loads at different branches, different elements. So here we have a multiple of models. So we have the plumbing, sprinkles, but yeah, let's turn off the architecture and let's also turn off the structure. And then let's just try to move a little to see all of those internals of that building. And as you can see, there are a lot of them. And the loading time was super fast. And also the performance in the web viewer is great, I would say, superb. So this is something which is really unique for the Xeokit. And the question is why? And during the hackathon, I had the pleasure to talk with the author of the Xeokit, Lindsay Kay, and he is the web developer who is working in this area for quite a long time, I would say. And the Xeokit, unlike some other viewers, is not based on the Tree.js, but directly on the WebGL. So it makes that we are much closer to the internals of the WebGL. So there are quite a lot of different hacks or bypasses of the limitations, how to make it so fast. And truly, I am impressed about the speed of just the user experience for viewing such big models. So when we are talking about some bridges, some big infrastructure projects, then I would say that, yeah, that's the way how they should be viewed in the browser. So now I'm just trying to see what else is here. And as a structural engineer, I spotted something which I really am curious about, the holder tower. Let's see what is inside of that model. Okay, so those are quite big towers, 2 of them. And what we can do with them? Of course, we can, for example, yeah, just turn some slabs. So now we have the skeleton, the beams, columns, okay. And what we can do next? We can, for example, measure some distance. Let's try to measure the distance between that beam and, that column and that column. Those are 6 meters, okay. Let's go with something like that, the height of that one. Okay, here I see some prefabricated connections. Nice, and that's how it works. Probably in that IFC model, those slabs, yeah, those corbels were annotated as slabs, but that's the IFC issue. Okay, so what we can do? We can also toggle some navigation, and now with my arrows I can just rotate the camera and probably move forward or backward, but yeah, that's not very useful in the day-to-day feature. We can also measure some angles, distances, all of that, what you would expect from the beam viewer is here. But as I said, the main distinctive feature is the performance. It's so amazing quick, but also for me as a developer, I love to see that code, to use it. And the Xeokit has the AGPL license, so you can use it, but if you want to sell the tool based on the Xeokit, you are not allowed to do that without the license with the Creoox. And now let's go to the pricing. Yeah, so if you are working with the open source, then you can use it, build on top of that something more. And the AGPL license, it means that you will have to expose also your code. But if you have the idea about some startup and you would like to use the Xeokit for your purpose, then you can just talk with Creoox, and they were on the hackathon, and they were very helpful in terms of the usage of the Xeokit. So you can always check their website. They are guys coming from the engineering background, so they have some other products like Hyperbeam, like Struct Tool, like Strat 3D. But those 3 are the standalone products applications. So if you need them, then you just go to the Creoox and buy the license for that. The Xeokit is a different story. So this is just the SDK. It's a very, very small word for such a library, because it allows you to build your own application. And the Creoox are not only the guys who are responsible for the pricing, but they are also the developers. So they probably, I'm not working for them, they will probably help you with implementing your idea based on the Xeokit. And as far as I know, when I heard some presentation from the Lindsay about the story of the Xeokit, it looks that many of the features which are inside of the Xeokit were introduced by other companies who are using that solution. So that's quite nice that, you know, this is something like a common library for the industry in terms of viewing big models. And we will go deeper into those details about how to use it, what are the use cases. But now I just want to showcase one very specific guy. He's from Finland, and based on the Xeokit, he created a magnificent application. But yeah, I just need to find his work. Okay, I found that guy, Joonas Koistinen, guy from Finland who is a structural engineer, but had an idea, and that's so great that he had the real engineering problem, the problem of optimization of the crane location. So based on the Xeokit, he built his own tool, which is able to help him in picking the right location for the crane. And there are multiple factors which influence that particular choice. So he used his deep engineering knowledge together with the beam viewer to create something completely new. And, you know, he was on the hackathon and we had a talk, and I was so amazed that he realized his passion and he learned about the Xeokit, about the JavaScript, all of that, because he had the knowledge and he felt that there is a need for creating such a tool. So, Jonas, you are truly amazing guy. But that was possible because of the Xeokit. And I feel that that particular viewer, that SDK, it has a lot of potential, which we will try to investigate in the next materials. So see you next time.